Second is dipole-induced dipole attraction or induction effect. Okay. This type of force is present in a mixture containing polar and non-polar molecules. This type of force is present in mixture containing polar. Example HF. Containing polar. Example HF. Polar and non-polar molecules examples S2, O2, N2, etc. This is non-polar, okay? This type of force is present in a mixture containing polar HF and non-polar molecules H2O2 and 2 etc. The positive end of polar molecules attracts the mobile electron cloud of the non-polar molecules towards itself. Thus, the non-polar molecules become polar due to induction. Thus, the non-polar molecules becomes polar due to induction. This is polar. This is polar, and this is non-polar. Non-polar. Is that this is negative, positive, permanent dipole. Permanent dipole, and this is plus, minus, and this is induced dipole. Induced dipole. This is induced dipole, okay? Induced dipole is called Dewey forces after the name of Peter Dewey, who discovered in 1920 the Dewey energy. ED is given by the equation ED is 2 alpha mu square upon r to the power 6, where alpha is the polarization of the neutral molecules. Alpha is the polarization. Alpha is the polarization of the neutral molecules, and r is the distance between the centers between the centers of the dipole, and mu is the permanent dipole moment. Permanent dipole moment of the molecule, okay? Alpha is the polarization of the neutral molecules, r is the distance between the center of the dipoles, and mu is the permanent dipole moment of the molecules. The interaction between two polar molecules is greater than the interaction between polar and non-polar molecules. Hence, Keisham forces are stronger than Dewey forces. Keisham forces is stronger than Dewey forces. Okay? Dewey forces. Thus, these are extremely weak forces and are confined to solution of polar solvent. In non-polar solvent, hydrates of noble gases xenon 6H2O is found by the interaction of this type. Okay. Third forces is instantaneous dipole induced. Third forces is instantaneous Third process is instantaneous instantaneous dipole, instantaneous dipole induced dipole interaction, dipole interaction, dipole interaction are induced dipole, are induced dipole, induced dipole, induced dipole, okay? Are induced dipole interaction, are London forces, are London forces, London forces, okay? These forces are found in non-polar molecules such as diatomic gases like H2, O2, Cl2, N2, etc. as well as monoatomic noble gases like helium, neon, argon, krypton, etc. A non-polar atom or molecule has a positive center. It is surrounded by negative electron cloud. Both are in equilibrium. If symmetrical movement of the electron cloud becomes unsymmetrical for fraction of a second, due to which one end of atom or molecules becomes positive and other negative. Thus, the dipole of electron cloud produced an instantaneous dipole temporarily. Hence, the non-polar molecule is self-polarized and become temporarily polar. The atoms or molecules get attached to each other due to the electrostatic force of attraction between the instantaneous dipole and induced dipole. Instantaneous dipole induced dipole interaction is shown. You can also, this is positive negative, and after some time this is positive negative, and after some time positive negative, this figure A, this figure B, and this figure C. Positive, negative, positive, negative, positive, negative, positive, negative, and this is positive, negative, this is positive, negative, this is whole positive, negative, okay? Instantaneous dipole induced dipole interaction. In this figure represents a non-polar, non-polar. In this figure A represents a non-polar molecule with a positive center surrounded by a symmetrical negative electron cloud, but B figure represents the displacement of electron cloud makes the non-polar molecules temporarily, and this C figure represents temporary polar molecules polarization the neighboring molecules and create in the induced dipole. And third, in this way a large number of non-polar molecules become temporarily polar, which are mutually attracted by weak attractive forces. These forces may be found and broken quickly. According to Fringe London, in 1930, the instantaneous formation and decay of dipole in gas. You can also show how to. This is the. And how to change negative positive. How to change negative positive. How to change this is positive, negative. This is negative, positive. This is negative, positive. This is negative, positive. And this is positive, negative. This is positive, negative. Okay? And this is the instantaneous formation and decay of dipole in gas. Decay of dipole in a gas. This type of weak intermolecular forces are called as London forces. These are weakest forces than other forces. These are responsible for the bridging, bringing about the condensation of gases, event of noble gases. This formation becomes stronger with the increase of number of electrons in the molecular atom. The force becomes stronger with the increase in boiling point of the molecules. Okay? And fourth is a ion dipole interaction. Ion dipole interaction. Fourth is, and next is ion dipole interaction.